Bismillahirrahmanirrahim. Assalamu alaikum dear students. You are watching Study with Sheraz, and in today's lecture we are going to talk about the Rutherford's atomic model. Basically we are studying the nuclear chemistry, and in today's lecture we are going to talk about the Rutherford's atomic model. First of all, we have to understand what was the practical setting of the Rutherford's experiment, and then we will move toward the observation and conclusions of the Rutherford bombarded the 4 into 10 to the power minus 10 centimeter thick gold foil with the alpha particles and made following observations. But before going into the observations, we are focusing on the practical setting of the Rutherford's experiment. So this was the Rutherford's experiment setting. In this experiment, he used the 4 into 10 to the power minus 4 centimeter thick gold foil. It means that the gold foil was very thin. The gold foil was just having a single layer of the atoms, and he used a radioactive material such as the polonium or radium to produce the alpha particles, and then he kept the gold foil as a target. He made the alpha particles to fall at the gold foil, and then a screen, or you can say a photographic plate, was kept on the other side of the gold foil in order to detect the alpha particles and in order to trace the path of the alpha particle. These were the alpha radiations that were produced from the radioactive source. So these circles are showing the single layer of atoms of the gold that were present in the gold foil. So these circles are showing the position of atom, and the dots in the center of the circles are showing the nucleus, and the surrounding space is the outer space of the atom. We have a separate video in which we explain the structure of the atom, what is the nucleus, what is the composition of nucleus, and what is the outer space. So if you have not watched that video is present at the end screen of this video. So you must watch that video in order to have a better understanding of the nucleus and the outer space of the atom. This was the zinc sulfide coated photographic plate, and it's a plate that gives flashes when alpha particles strike the plate. So this plate was used to trace the path of the alpha particles, and he observed that, as you can look here in the setting, that most of the alpha particles are going straight. Few are being deflected at very high angles, and a very few alpha particles were made in such a way, their path was made in such a way that they bounced back toward the source. This was like the bouncing back of alpha particles. A very small number of the alpha particles were deflected and some were bounced back. And after this experiment, he made some observations, and these are the observations of the Rutherford. So first of all, there lies positively charged tiny portion in center of the atom called nucleus, and it's a massive portion. After studying the bouncing back of the alpha particles, as you people know that alpha particles are highly positively charged particles, and chemically these are the helium-2, and basically when they are converted into the alpha particles, they have a charge of +2. So Rutherford got the idea that as the alpha particles are also positively charged, and when they are bouncing back from the nucleus, so it shows that nucleus is also a positively charged portion. The deflection of the alpha particles at certain angle shows that the nucleus is massive. It is having some mass, and whenever another particle having the mass strikes with the nucleus, it is deflected from its path. And he said that the nucleus is positively charged massive portion. The second observation was that electrons are distributed in space around nucleus, number equal to the protons. He said that the electrons are not present in the nucleus. These are distributed around the nucleus. These are distributed in space around the nucleus, and the electrons are having negative charge, and the negative charge, or you can say the number of electrons, is equal to the number of protons in the nucleus, because he observed that as a whole the atom is electrically neutral. Third observation was that there is empty space between nucleus and the electrons, as a large number of the alpha particles went straight. So he said that between the nucleus and the paths of the electrons, there is a large volume of the space that is empty. He drew some conclusions. The first conclusion was that nucleus contains protons and neutrons. As in the previous video we talked about the nucleons. So protons and neutrons are called the nucleons. And why they are called the nucleons? Because they are assumed to be present within the nucleus. The point number 2 is electrostatic forces bind electrons to the nucleus. He said that the electrons are not freely wandering here and there in the space, but they are under the influence of the nucleus, and there is an electrostatic force that holds the electrons, that binds the electrons with the nucleus. Third one is the size of the nucleus is measured in Fermi unit. So he said that the nucleus is a very small portion as compared to the rest of the atom, and its size is measured in the Fermi unit, and 1 Fermi is equal to the 10 to raise per minus 13 centimeter. That's a very small factor. Diameter of the atom is of the order 10 to raise per minus 8 centimeter. Size of the nucleus is 1 by 1,000th of the size of the atom. So he concluded that the nucleus is very small, 100 times small as compared to the size of the atom or the whole space of the atom. Nucleus is highly dense as compared to the outer space, because nucleus contains nucleons, protons and neutrons, and these are massive particles as compared to the electrons. So the density and the mass of the nucleus is very much as compared to that of the outer space of the atom. So this was all about the Rutherford's atomic model. If you have any question related to this video, you can post your question in the comment section. We will meet in the next video. Up till then, Allah Hafiz.